All right, in that last video, we mentioned a couple of logarithms that were more special than others. These two right here. So this one was true because uh, anything to the 0 power is equal to 1, and anything to the first power was equal to itself. Okay. I got one more that I want to show you that's just like this. It's special, and it's a lot like this one actually. It's just a special case of it. If I'm looking at, say, log base 2 of 2 to the 8th power, if I were to translate this in the little exponential world, it would be 2 to some power, right, is equal to 2 to the 8th. All right, so I think the answer is obvious. It has to be the 8th power. Right? So anytime where your base here and your base here are the same, whatever the exponent is, that becomes your answer. All right. In general, the formula for it would be log base anything of anything to the nth power is just going to equal n, right? So anytime that your bases are the same, they kind of just cancel each other out, and you're left with whatever the exponent was that you had started with. Okay? This is actually happening because logarithms and exponentials are inverses of each other. Just like square roots and quadratics, yeah, square roots and things to the second power are inverses of each other. You know, if you had some number squared and you square rooted it, you're just left with x because the square root and the square cancel each other out. That same thing is going to end up happening with when you combine a logarithm with an exponential, as long as the bases are the same. All right, so those things are inverses of each other. I know last year we mentioned inverses. We had talked about inverses are always a reflection of each other across the line y equals x, and that's true. We had mentioned the stuff where the domain of one is the same as the range of the other. There was that relationship, and that's true as long as your bases are the same in the logarithm and the exponential. All right, but I'm going to use that fact to solve exponential equations. So because logs and exponentials are inverses of each other, we can use them to solve exponential equations. We're going to do 6 to some power is equal to 40. All right, we'll look at this one here. So this is not like the ones that we've solved before where we were able to just rewrite them as, the same base. Like I can't express the number 40 as some power of 6. But what I can do is I can use this little logarithm fact to figure out how to solve this. All right? What I'm going to do, the scheme is I'm going to take the logarithm of both sides, base whatever the base is I have here. Okay, so I'm going to do log base 6 of the left side, right? 6 to the x. And I'm going to say that that's equal to log base 6 of the right side. Right? I'm just taking the log of both sides of the same base, but I'm choosing the base to be the same as the base I started with here. Now doing this is going to end up solving this equation for me. All right, because I have log base 6 of 6 to some power, the log and the exponential part just cancel each other out, and so I'm left with x. And the right-hand side is actually my answer. All right, log base 6 of 40 is my answer. Later on, I'll show you how to figure out what this is as a decimal. But that is my answer in log form. Grab a calculator real quick, and I'll tell you what that is. As a decimal, that would be 2.058. All right, this is approximately equal to 2.058. Okay, I'll do one more little exponential equation just so you have a couple of examples. But to solve an exponential equation, it's really just as simple as taking the log of both sides. That's how you do it. Right. So my base is 8. In order to get rid of this little exponential junk, I'm going to take the log base 8 of both sides here. So I'm going to do log base 8 of the left side, 8 to the x minus 2. And I'm going to do log base 8 of the right side. Log base 8 of the right side. All right. On the left side, the log base 8 and the exponential part, they're just going to cancel each other out. They're inverses of each other. And so you get x minus 2. Log base 8 of 500. And then the last thing you have to do is just plus 2 on both sides. And that's your answer. X equals log base 8 of 500 plus 2. I'm going to figure out what that is as a decimal. Looks like it's close to 5. All right, this is approximately equal to 4.988. All right, but this is our answer right here in log form, all right, in exact form. All right, that's it.